In this lecture, we will learn about some of the built-in character encoding functions that Python gives us access to. To start off, we are going to want to have an ASCII character table open that we can reference. Let's open up the web browser and go to asciitable.com. You will notice that there is an ASCII table. Let's go over how to use it. As we learned a few videos back, ASCII contains a total of 128 characters. Notice the numbers 0 through 127 in the leftmost column. The HX column shows the hexadecimal, aka hex values for these characters. The oct column shows the octal integer representation of these characters. HTML shows the HTML encoding information for these characters. And char shows the characters themselves. For the first example we are working on, we will be referencing the @ symbol, number 64 on the ASCII table. Let's open up PyCharm. The ORD function allows us to convert a string to a base 10 ASCII code point. Put simply, this means that we give it a string, and it gives us back the number of that string on the ASCII character table that we just looked at. Recall that the number that corresponds with the @ symbol is 64. We can print out the result of a call to the ORD function and pass in the @ symbol. When we run the code, notice that the ASCII value of is 64 was printed to the console. The next function that we will learn about is the bin function. Bin will take in a number and give us its binary representation. For example, we know that the binary value of 10 is 1010. How do we know this? Binary is base 2, so the first spot to the right is 0. The second spot to the right is a 1. This slot represents 2 in the base 2 system. Then comes another 0. This slot represents 4 in the base 2 system. But since it is a 0, so far we only have a total value of 2. The fourth slot over is a 1. This represents 8 in the base 2 system. 8 plus 2 equals 10. To prove this, let's print out the result of a call to the bin function with 10 passed in. When we run the code, notice that OB1010 was printed out. The 1010 we expected, but what about the OB part? OB is what precedes any binary number in Python. This is just the computer letting us know that anything after the OB is actually binary code. Next, we will learn about Python's ASCII function, which gives us the ASCII string for an object. For example, let's print out ASCII with Python passed in. Except notice what I did. I added the O with the 2 dots above it. I'll teach you how to get this character in a moment, but before I do that, I will run the code. Notice that the word Python was printed to the console, but instead of that special O, we get a value of \xf6. This is the Unicode string value for that special character. To prove this, let's print out the string \xf6 to the console. When we run the code, you will notice that the Latin small letter O with diaresis was printed out. This proves that the string \xf6 corresponds to that special O character. In the next lecture, we will learn about Python string literals.